before our next speaker. Just as people walk in, just a couple of housekeeping things. Lunch isn't catered today, so there's about an hour and a half break. Go find somewhere to grab some food. And importantly, this evening dinners, we've got a bunch of reservations made, but you need to put your name down for one of them, or else the reservations will be cancelled. So if you go to the PyCon website, then to under the program, there's a social events page, and you can put your name down there. It might be cool if we actually had a couple of tables for OpenStack people. So if anyone's had a look at that list and knows anywhere good to recommend, feel free to shout that out. But otherwise, do put your name down, or else you might struggle to find somewhere to eat. Anyway, we've got a couple more minutes before the next talk begins. All right, we'll get started with our next speaker. Our next speaker is Robert Collins, who's going to be talking about Python build reasonableness. Robert works for HP and lives in New Zealand. He didn't give me a bio, so I can say anything about him and it will be true. However, I'll leave him to give his talk instead.
So at this point, I guess we do the mic check and see whether I'm... Yep, everyone's happy at the back. Okay, so PBR is a kind of interesting project, and I think the best way to lead into it is to get my mouse in the right window so things work. So I think it was in LCA 2006 where Anthony Baxter described distro-tools and setuptools as very clever people, very clever code, and then very, very clever code written by very clever people, which no one else can understand. And it turns out that, well, OpenStack needs to use that. And we've got lots and lots of fairly straightforward code, but we've got a very complex environment. It's distributed, it's concurrent, everything that can go wrong in terms of making an environment hard to debug, we've got all of that. And dozens of projects. And every single one of them, a few years ago now, every single one of them had exactly the same code in their setup.py. And every time we found a bug, it would take weeks to fix it because you had to roll it into one project after another, after another, after another, wait for everyone to approve them, and then you could finally get on with your day. So there's a fairly standard pattern when you run into this sort of thing. You refactor, right? Bring it all together, one place, consistent glue, everything solved, no more problems. Well, maybe there's a couple of little quirks. Gee, did I just skip? I did. I'm terrible. Sorry. So anyway, we brought in PBR, and it brought everything together. It also added another abstraction layer. And what problem can't we solve by adding abstractions? Abstractions themselves. So it's a new project, and it's a setuptools plugin. So this is the point where we now have to write code that interacts with very, very clever code written by very clever people and make it work across dozens of projects without fail. And it also has to work for a fairly complex CI system, and it has to work for distributors who are distributing it in distributions and maintaining it for years and years and years and years and years, because there's some crazy people out there. And it has to work for people who are deploying trunk every day, and yeah, it's fun. But the key thing about it from an OpenStack perspective is because every single OpenStack project uses it, it's got huge leverage for fixing things. So I am jumping all over the place. I'm sorry about this while I find out what the hell is going on. There, that slide. There is an entirely missing slide here. Right. Next time, use a presentation tool I've used before. So anecdotally, within HP, everything runs on PowerPoint, and I just can't stomach that. And I've been using LibreOffice to sort of survive in the corporate environment, and my soul is dying. So I needed to find something else that could kind of bridge that gap. And Reveal.js has been a shiny thing for a while, so I was like, okay, it's time to dive in and make a theme that's kind of got the HP colors and maybe the fonts. And that's why I was writing the actual content of my slides this morning. The last bit. Anyway, so the key thing I think for PBR, it's a Python project. Anyone can use it for any Python project as long as you use Git for your source code and you're able to depend on a fairly recent pip. Some of the stuff it does for installation well, there were genuine bugs in older pip, and it's just best to say use a recent pip if you're going to use pip at all. So is that code block there actually visible? It looks like it's kind of terrible. All right, so that just says Python setup.py test. And I suspect it's clamped to the, yeah, okay, so the CSS needs tweaking. So one of the things we found, old OpenStack ran with nose tests, and OpenStack as a whole wanted to move away from that for a few reasons, but as they moved away from it, they found that everyone got terribly, terribly confused. They'd brought in a wrapper around those tests, which was a shell script. It wasn't tox, and it ended up, that thing then wrapped tox. And we had at one point, I think, 7 or 8 months worth of different, this is what you should run, answers being run concurrently by people, and every time someone changed something on the assumption that, yes, everyone's caught up now. Yeah, the answer was no, they haven't. So setup.py test will now run whatever the standard is for testing in that particular project. It doesn't call into tox, so if you're going to set up a virtual env or something else, you do that around it, but you don't need to know what the actual specific test runner that that project uses is anymore. And the Git integration is a hard requirement, but it's got some benefits. So it automatically picks up all the version files in your tree, puts them into your setup, into your tarball. It scans the history, builds a changelog in a fairly unoffensive format. It may not be the perfect one, but it works for all of the OpenStack projects. And it creates an authors file with the name of all of the authors that have contributed to the project. So you don't need to say, thank you for your patch. Now I'm going to go and manually edit this file and see if you're already in it, resort it in my current locale to find you. No, just forget about all of that. It goes away. And when you push up to PyPy, one of the things I used to have to do for all of my projects was manually create a little bit of code that took up a README file I had in my tree and put that into the long description so that when you go to the PyPy page, you see something other than project name tarball, which isn't a very friendly or useful experience. Instead, you want your README there. We use Sphinx across the board in OpenStack. And again, this was one of the places where we had slightly different glue turning up in place after place after place. And there's some stubs you need to create to get API docs in Sphinx. And PBR knows about that and can generate those automatically. And it turns on man page output. Again, because we've got such a close relationship with distributors, having man pages for all of our things, kind of useful. And this pip thing, this is another case where we've got this redundancy. So and it's at 2 levels. When you want to use easy install, you've got to list your dependencies in one place. When you want to use pip, you have to list them in a different place. And that's one level. So we consolidate that, and we just have a requirements.txt file or a test requirements.txt, and maybe a Python version specific one that you put the requirement in once and it applies to both pip and easy install. Fantastic. But the second place where we've got redundancy is that we then have 20, 30, 40, I don't know how many projects we're up to now, all of which have slightly different requirements files. We haven't fixed that one yet. At the moment, what we do is we write it into a global requirements in a separate tree, and then we go to all of the other ones and we copy it out. I don't think that's sustainable, but we don't have a better answer yet. And I'm very sorry about this sore throat. I was absolutely fine yesterday morning, and I blame my daughter, who my wife has told me is currently sick and crook. So I know it's coming down the line for me, and I'll try not to give it to any of you. I suggest you don't kiss me. So versioning. This is actually the bit I really wanted to talk about in this talk. The rest was just giving you background. I hope it wasn't too boring. With current releases of PBR, when you do Python setup.py sdist, it creates a version number for you. So if the last tag you have in Git was 1.3.2, it will give you a version like 1.3.2.5.g and a bit of Git hash. And what this is really saying is it's the 5th commit after that tag, and this is the hash of the local tree. So for a local developer, you can do a commit, install a new version, it will work. Those version numbers are it doesn't really support you in creating new version numbers. It just gives you a version that is reasonably unique for what you've got in front of you. But let's talk about consistency for a second. Most projects have one version scheme, right? You know, I'm going to do semantic versioning, or I'm going to do odd numbered releases, even numbers dev, 1.3, you know, that's a dev, 1.4 is a release. Or I'm going to do years and months, 2010.2 is the next release if you're in 2010. My time machine works backwards. The lovely thing about OpenStack is we do 2 of these at once. Our API servers do year, month-based versioning. So first component is year, second component is month, third component is a serial number. And our clients and libraries do something that currently approximates semver and is meant to be semver. So yeah. Semver, who here doesn't know what semver is? Okay, so semver is a set of rules for when you should change your version numbers so that people who are depending on your API can make really well-informed choices about how they depend. So, for example, if you're in a semver world, and you should never just pick up a new major version because you know that any major version that comes out is going to have backwards incompatibilities in it. Either they deleted deprecated functions or they've changed the part of the contract in a way that won't work. It might not affect you, but it might. But equally, if you stay with the same major version number, everything will work and it will never break, assuming that the authors have actually implemented their semver assessment about changes correctly. Mistakes happen. So we adopted semantic versioning a couple of years ago in OpenStack, and it didn't work for us. We found out that there was some friction, so we created an OpenStack variant of semver. Specifically about distributions. And the pre-release labels and build labels are all about being able to put binaries onto people's machines and be able to tell where they came from and whether or not they'll work. However, even with that, we still have some issues. Firstly, current PBR. This is all about current PBR. If you have a tag 1.3.2 in your tree and you do a development build, you'd want a version that looks like an alpha or a beta. It's not going to look like a full release to someone who is tracking actual releases. So that's why what we do is we create a full release. Our developers, we got, I think it's over 2,000 contributors now to OpenStack, and about 1,500 are active in the last 6 months. So this is a huge number of people. It's a smaller number of people doing releases, but even so, as I said, dozens of projects, so you're probably looking at 50-odd people who need to be trained on doing releases to make sure releases are done properly. And with the CI and infrastructure that OpenStack has, doing a release is doing a tag and a push. So it's actually very easy to get wrong because there's not a lot to do to make it happen. And in PEP-440, this is not a valid PEP-440 version string. This, it's not a version, sorry, go home. I mean, you can, is it now? All right, this wasn't a valid version string. That is actually the valid version string, was the only valid version string, may now be obsolete. Okay, fine. Wow, that... There you go. Is that better? Both are less scratchy and the mouse out of the way. So, what else is there? Continual deployment. If you're deploying from trunk, you want a monotonic version. Every time you get another build of trunk, you want to make sure it's going to be higher than your local version so it installs properly. Development versions, you just want to install what's local, so you want a different version number, and you're going to be forcing it. You're not going to be depending on a package repository like dpkg or RPM to be doing the right version comparisons for you. Problem is that, as I've put up there, in semver, there's no distinguishing sort order between dev versions and alpha versions. There's no concept that a dev version is before or after an alpha. They're in separate timelines. And that's a problem. So we needed to solve that. And, oh man, binary packaging. Everyone reinvents I'll just take an upstream Python sdist release and I'll put it into my Debian package or my RPM package differently. Every single time. There's some little corner case they manage to get different. I'm not saying wrong, just different. And what we're trying to do here is to get good answers and get it consistent so we can write documentation and we can teach lots and lots of different people about how it's going to work. One particular thing is this sort before primitive. So an alpha release of version 1.3.2 should come before version 1.3.2. In dpkg, you can use a tilde to say to the left and to the right, and this is going to sort before. So you can write 1.3.2 tilde A1, and it's a pre-release of 1.3.2. In RPM, I'm not aware of any equivalent mechanism or hack. So we've got some pretty awful stuff I'll come back to later. And this leads us to the actual, we're now doing a spec, which has been approved in Oslo, and most of the patches are up for us and just percolating through review, to do semantic versioning support directly in PBR. So the first thing is, and it's new, and it's shiny, and it's magic. And I'm driving this largely because I have a bunch of projects that are currently in BZR that I want to move over to Git, and I don't want to have to go and write new glue to do stuff I already do in BZR in the Git world. So it's like, okay, let's do it once, do it right. So the first thing is, all of these version numbers, if they're not PEP-440 compliant, we're going to reject them when you try and build a local sdist. So this will avoid bad tags being made, we hope. Go on, Nick.
We need to talk.
Well, sure. If PEP-440 would stop changing, this might be easier. Yeah? That's it. Yeah. So I'm happy to talk. Modulo throat. Of course, this epically fails if your existing tags aren't. Just for the rest of this talk, pretend. No. New things are fine, but I know there's a delta there, but I'm sure that every tag out there isn't actually going to be PEP-440 compliant. I hope. Yeah, I love Donald. So yeah, so the problem is that we have to accept every single version and turn it into a semantic version. So this, to a degree, this is PEP-440, but it's also be able to guarantee that we actually understand what that version was, so that when we output it in the current format, we do the thing correctly. And some of these are fairly easy to get. Some of them are a bit harder. I think we've got all the code in place, but it's a horrible parser because we wanted to keep the dependencies lean. We didn't want to depend on PyParsing or something in something that's going to be pulled in by easy install when you install your package. Got to keep it very lean. Secondly, history scanning. We need to do a lot more than we currently do. At the moment, we just figure out how many commits since the last tag. That's not really enough. What we need to be able to do is, instead of generating this new so I don't know if I explained enough about semver. I'll touch on it just one last little bit. Semver has the concept that you have a major, a minor, and a patch level. And if you're doing something that semantically the project is the same, you change the patch level. If you're adding some functionality or you're deprecating something but you're keeping it round, anything that people actually need to know about, you change the minor version. And if you're breaking something so that existing code will stop working, you change the major version. So if you've got a commit into PBR that currently generates a version of 0.10.1 dev 5, and this is such a commit, you can now add headers to it to say this is a feature commit. So the second last line, semver : feature. and that will automatically update the version, increment it to give you 0.11.0. If you put feature, does that. API break will update the major version. Deprecation updates the minor. Bug fixes update the patch. If you don't put the header in at all, we assume it's a patch. And you can put multiple comments in there. So this is meant to be a communication tool as well as driving the automation. In the same way that we currently in the OpenStack commit logs, we have things like doc impact and deployer impact or release impact. This is in the same sort of space.
Why do you need to do that? Should you need to rely on the bug fix and blueprint? And just like people are going to forget about that notes. You know what I mean? Reuse the
So those aren't used all that consistently, and implementing a blueprint doesn't imply that it's not an API break. We don't have any marker that actually. So you could infer from a broader set of things, but we felt that being really clear about this drives this thing is actually kind of useful in its own right. Particularly since PBR is used by more people than just OpenStack, and we don't necessarily want to enforce the insanity that is blueprint process on other projects or on small projects. I mean, there's a tension there, I think. Look, we can discuss it after this. I'm happy to go back and make a change to the spec and see what Doug says. But the thing that this gives us that I'm really excited about is that you no longer need to think about what version you're going to release. So you can just say, at the top of this patch set, you'll be able to just say python setup.py tag release, and you get a release out with the next version calculated out of your history. So at the moment in OOO, we do a release of all of our projects every week, and that involves looking at history to figure out what API breaks, if any, have happened. That's the key thing. You can't just monotonically assume there aren't any. And if there are some, obviously that should be a big decision to do it. But this gives us automation to not have to think too hard. For binary builds, we'll be able to query, set up to get a Debian version or an RPM version out of it. Note the 9999 thing to emulate sort before. We drop down to a fourth component of the version before in semver to emulate it. It's terrible. I said it would be terrible. It really is terrible. But we think it will work well enough that we don't need to think about it after we get this done. I mean, it's not aesthetically pleasing, but that's not really the goal of it. The goal of it is to be reliable and automatic. And Nick's smirking in the corner. He's going to tell me something I really wish I knew a week ago.
We need to talk about the RPM release.
Okay. One thing that this is kind of a title thing. There's a thing in Python itself called version info, which is a tuple that describes the version of Python. It's not as rich as semver, and it's got a couple of differences, but we can translate semver into that, at least for releases. Dev versions are the ones which it doesn't quite fit. And that some projects use that, and it's really, really easy. Just these two lines in your init.py, and PBR will figure it all out for you. And for the continual deployment case I was talking about before, that is fairly easily solved. I managed to delete the no RC on that, didn't I? So the second one there, the difference between those two examples is the first one is showing the current tag, it's an alpha release. The second one is saying, hey, this is what that would be if it was a dev version. So essentially you've got an alias to the same commit that will occur on any actual pre-release tag, and that means you can get a single timeline for continual deployment. So for continual deployment, you'll just ignore whether something is an alpha or a beta or an RC. You'll just say, look, it's either a release or it's a dev. Now, I realize, so how many people here are actively involved with OpenStack? I mean, everyone knows what it is, but who's contributing to, right? And how many is using it? Right, and then the rest are just interested, I presume. No hands go up. So the monotone is working. Everyone's getting their nap in nice and early in the morning. So to get started with PBR, it's really easy. You need a 4-line, 5-line if you want to be able to do /setup.py, setup.py. Just import it, call it, done. Put it in Git, obviously. Yeah. And secondly, oh, I'm so sorry. Secondly, you need to have a setup.config file, which is a declarative form of setup.py. There was a project distro-tools 2, D2, and a D2 to 1 that we kind of included and got us going with this. These days, I believe we've got a complete re-implementation of that because it kind of petered out. Once it becomes a approved and landed spec and not a PEP and not a draft, we'll probably have a little bit of adjustment to do. But it's really straightforward. Everything essentially maps directly across. And this is an example from one of the OOO projects, off-supply config, which is a little templating thing. And you can see it, it's very little there that's not actually specific to this project. So we got rid of all of that boilerplate that I was talking about before. Okay, so questions. These are meant to come from you to me.
So you were saying you need to determine, you need to make sure that developer builds are different to alpha builds. Are you expecting alpha builds to be tagged as an alpha?
Yeah, so the way an alpha is done in the OpenStack infrastructure is that you tag a version as 1.3.2.0A1 and you push that tag up to Herit, and Herit then uploads that to PyPy. And if that hasn't happened, it doesn't really exist. Now, if someone is tracking trunk, when they pull it down, they'll get that tag, and when they run sdist locally, it will create an alpha sdist rather than a dev sdist, and that's in a separate timeline, so they can't actually compare visually. I mean, they can just install it directly, but if they then wrap that into RPM or dpkg, which is what happens, the versions don't sort in any appropriate fashion. Nick's maybe got an answer for RPM. Oh, good. I'd love to drill into that. Cool. Going once? Yes.
You mentioned differences between PIP and setuptools and problems there and trying to work out. I was just wondering what the use case was there between the two and what the solutions were.
So the solution we recommend upstream is to never use easy install and to always use pip. When you do setup.py install thing, if there are dependencies of that setup.py that aren't installed locally, setuptools goes and triggers the easy install code path and then downloads with its own implementation of a bunch of stuff it shouldn't have needed to implement from PyPy, locally installs it, and doesn't actually install it, locally unpacks it in the root of the tree you're in, adds that to your Python path, and then chains into the actual setup.py code. And that's done through the setup requires keyword. Now, if you run pip install dot in the same situation, it will look at your, I forget the PEP number, metadata that declares declarative dependency format, which you'll have if you've grabbed this off a table, and Nick's got an answer.
They cover slightly different cases. So it looks the requirements.txt is a project specific integrated file.
So no, you're actually slightly wrong there. So pip install dot doesn't look at requirements.txt. Pip install dot is looking at the declarative metadata for dependencies, and one of those dependencies says it requires PBR. It will then install PBR, and then you chain into the Python, into the setup object, and then the setup object can say, by the way, I have a bunch of other dependencies, and requirements.txt can be consulted there for the uncommitted case. For the committed case, sorry, for the sdisted case, you've got all the metadata there already, and pip will grab all of them straight up. But it doesn't actually know about the requirements.txt file. That's what we use as our authoring tool. It all gets reflected into either explicit metadata or a dependency list on the setup object. Right, right. So basically, setup tools bad, pip good. I mean, I don't know how much detail.
Very
Clever code written by very, very clever people. Yes.
that nobody else understands.
Yes. I mean, does that answer your question, though?
Yeah.
Yeah. Okay.
You said blueprints and stuff, but that looks like when code is sort of gone. How long before we start seeing this?
So the top of the stack is where, there's a bunch of refactoring stuff that has been landing and is in 0.10. The actual meat of this, I hope, will be 0.11. It's some of it's passing CI, other ones have got little bits of glitches left to fix, and then we've got to get it approved, and so on. Yeah. So I don't know, a few weeks, month tops.
What's your timeline to 0.11?
If you can give me another +2.
No, I'm saying we need to talk.
We're going to talk. You're going to buy me alcohol for my throat, and I'm going to listen to you.
This is why we have these conferences.
So it sounds like, so the gateways that we need to get through are code review, actually landing it, testing it out to make sure it doesn't break any of the API servers or anything. I'd like to make sure it's in for Juno. It sounds like some of the design may be redundant with PEP-440 evolving things, but if we're tighter than PEP-440 and have more constraints, I'm not worried about that. I'd be more worried if we do something that's incompatible with PEP-440, in the sense that we do something PEP-440 won't accept.
We just need to make sure we're solving this
Like,
problem in a similar way.
yeah. Awesome. Okay, so who's got a torch so I can see your hand asking for a question? Like, really, I can't. Yeah, no, I just can't see if anyone's got their hand up.
I think the room looks like it's done. I don't think it can.
Okay,
Okay. Thank you, Robert.
you're welcome.